Good morning, everybody. My name is Roberto La Rosa. I am a PhD student at EPFL Lausanne and senior member of the technical staff for ST Microelectronics. Today, I have had the pleasure to present, also on behalf of my co-authors, a system for the control of the ambient light, which has the peculiarity to exploit energy harvesting in order to be energy autonomous and battery-free. In this presentation, I start introducing the problem to further reveal how we solved it. I will describe how the system works with particular emphasis on energy harvesting and light sensor functions. Moreover, I will show how this solution can null the maintenance problem of wireless sensor nodes in an endless application scenario. The main problem we discuss is the maintenance of wireless sensor nodes. As a matter of fact, as of today, wireless sensor nodes are battery powered, implying a periodic battery replacement that is a costly operation, especially in wireless sensor networks with a large number of nodes. Therefore, along with being wireless, compact, and low cost, a good requirement, if not mandatory, for a wireless sensor node is to be maintenance free. To this purpose, our solution exploits energy harvesting to implement an energy autonomous and battery-free device, which implements Bluetooth Low Energy communication, which is easy to configure and a truly set and forget that does not need maintenance in its entire lifetime. The applications of these devices are practically endless. Indeed, this is a light intensity measurement device that has the peculiarity to be set and forget. Therefore, it can be used to efficiently control the right light intensity in virtually any environment, which also is saving energy bills. All this without worrying about maintenance, because the device is still set and forget. It can be disseminated anywhere. To solve the maintenance problem of wireless sensor nodes, we propose an energy autonomous and battery-free device. This device as it is has the peculiarity of being also as a sensor-free device, and it does not need a specific light sensor. In fact, the light sensor function is implemented by the same transducer that harvests the energy. Therefore, the photovoltaic transducer performs simultaneously as energy harvesting and light sensor. The advantage of this is to use a reduced number of components for the double benefit of reduced costs and above all reduced power consumption. This reflects also in a lower energy to harvest and overall higher system performance. All this is achieved in a very compact device which has the size of a tag as big only 20 mm by 20 mm, which is very compact. This is implemented uniquely with off-the-shelf and low-cost devices. The way the system works is the following. The Bluetooth Low Energy radio emits beacons at a frequency which is proportional to the light intensity which is present in the ambient. Therefore, the higher is the light intensity, the higher is the frequency at which the Bluetooth Low Energy radio emits the beacons. This feature allows a remote base station, which is also equipped with a Bluetooth Low Energy radio in receiving mode, to receive the beacons, measure the frequency, and finally measure the light intensity which is present in the environment. Of course, it's an indirect measurement. In this way, also the reading of the sensor is easy to implement. In fact, the base station only needs to perform a frequency measurement of the received beacons, so that the sensor, in this sense, has a convenient time domain readout. The system consists of two different units, the energy autonomous device and the base station. The base station is a device that does not have problems with power and is typically powered through the mains. It is a control unit with a radio that can listen to one or more energy autonomous devices. The energy autonomous device, on the contrary, must be battery-free as it must be disseminated and installed even in hard-to-reach places. For this reason, it implements a photovoltaic cell that harvests energy and makes it battery-free. The harvested energy is stored in the energy storage device, which in this implementation is a small ceramic capacitor, since the energy to harvest at every cycle is as low as 1 millijoule. The power management unit measures the energy storage in the storage capacitor and turns on the Bluetooth Low Energy radio as soon as that the energy storage is big enough to accomplish a radio transmission. As a result, the system emits beacons through the Bluetooth Low Energy radio at a frequency that is proportional to the ambient light intensity. Therefore, a remote base station can easily derive the frequency of the received beacons and perform an indirect measurement of the ambient light intensity, through which can control rolling shutters, window blinds, dimmable lamps, and the like. The graph in this slide shows the experimental characterization of the system in terms of the time interval between consecutive beacons, as shown in the y-axis in seconds and the light intensity shown in the x-axis in lux. The graph shows that the system has a limited detection of 200 lux with an amorphous silicon photovoltaic cell of 15 by 15 mm square. According to this, the system emits beacons only if the light intensity present in the environment is higher than 200 lux. We can notice that the time interval between consecutive beacons decreases as the light intensity increases. The system can measure the ambient light intensity. For instance, the graph shows that the system emits beacons every minute if the light intensity is around 300 lux, which is the typical light intensity present in a classroom. It also emits beacons every 30 seconds when the light intensity is about 500 lux, which is the typical light intensity of a professional office. The idea is to use this information to monitor and control the luminosity in a given environment. In this presentation, I discussed an energy autonomous and battery-free wireless sensor node that does not need any maintenance. The system, in fact, intrinsically measures the light intensity without needing a dedicated sensor, as the single photovoltaic transducer simultaneously performs the double function of energy harvesting and light sensing. Readout of the sensor is in the time domain that makes it very convenient. In fact, to implement the sensor readout, the base station only needs to measure the frequency of the received beacons, and no complicated analog circuitry is needed. The outcome is a compact wireless sensor node with a 2 cm by 2 cm tag size that implements specifically low-cost and off-the-shelf devices such as the microcontroller STM32L0 and the Blennergy-LP radio provided by ST Microelectronics. The system can be used in endless applications such as home and office automation, precision farming, smart irrigation, and the like.